Good morning, good afternoon, and good evening, everyone. So welcome again to this session where we will discuss on Hadoop interview questions and we will learn on different aspects and be prepared for Hadoop interviews so that you can move into the big data arena. Here we have some list of questions and an explanation of those so that you can be well prepared for your Hadoop interviews. Now let's look at some general Hadoop questions. So what are the different vendor specific distributions of Hadoop? Now all of you might be aware that Hadoop or Apache Hadoop is the core distribution of Hadoop. And then you have different vendors in the market which have packaged the Apache Hadoop in a cluster management solution which allows everyone to easily deploy, manage, monitor, upgrade your clusters. So here are some vendor specific distributions. We have Cloudera, which is the dominant one in the market. We have Hortonworks, and now you might be aware that Cloudera and Hortonworks have merged. So it has become a bigger entity. You have MapR, you have Microsoft Azure, IBM's InfoSphere, and Amazon Web Services. So these are some popularly known vendor specific distributions. If you would want to know more about the Hadoop distributions, you should basically look into Google and you should check for Hadoop different distributions wiki page. So if I type Hadoop different distributions and then I check for the wiki page, that will take me to the distributions and commercial support page, and this basically says that the sole products that can be called a release of Apache Hadoop come from apache.org. So that's your open source community. And then you have various vendor specific distributions which basically are running in one or the other way Apache Hadoop, but they have packaged it as a solution like an installer so that you can easily set up clusters on set of machines. So have a look at this page and read through about different distributions of Hadoop. Coming back, let's look at our next question. So what are the different Hadoop configuration files? Now, whether you're talking about Apache Hadoop, Cloudera, Hortonworks, MapR, or no matter which other distribution, these config files are the most important and existing in every distribution of Hadoop. So you have Hadoop environment.sh, wherein you will have environment variables such as your Java path, what would be your process ID path, where will your logs get stored, what kind of metrics will be collected, and so on. Your core-site file has the HDFS path. Now this has many other properties like enabling thrash or enabling high availability or discussing or mentioning about your zookeeper. But this is one of the most important file. You have HDFS-site file. Now this file will have other information related to your Hadoop cluster, such as your replication factor, where will NameNode store its metadata on disk, if a data node is running, where would data node store its data? If a secondary name node is running, where would that store a copy of name node's metadata? And so on. Your mapred-site file is a file which will have properties related to your MapReduce processing. You also have masters and slaves. Now these might be deprecated in a vendor specific distribution, and in fact you would have a yarn-site file which is based on the yarn processing framework which was introduced in Hadoop version 2, and this would have all your resource allocation and resource manager and node manager related properties. Again, if you would want to look at default properties for any one of these, for example, let's say HDFS-site file, I could just go to Google and type in one of the properties. For example, I would say dfs.namenode.name.directory, and as I know this property belongs to HDFS-site file, and if you search for this, it will take you to the first link which says HDFS default XML. You can click on this and this will show you all the properties which can be given in your HDFS-site file. It also shows you which version you are looking at, and you can always change the version here. So for example, if I would want to look at 2.6.5, I just need to change the version and that should show me the properties. Similarly, you can just give a property which belongs to say core-site file. For example, I would say fs.defaultfs, and that's a property which is in core-site file, and somewhere Here you would see core-default.xml, and this will show you all the properties. So similarly, you could search for properties which are related to yarn-site file or MapRed-site file. So I could say yarn.resource manager, and I could look at one of these properties, which will directly take me to yarn default XML, and I can see all the properties which can be given in yarn. And similarly, you could say MapReduce.job.reduces, and I know this property belongs to MapReduce-site file, and this takes you to the default XML. So these are important config files, and no matter which distribution of Hadoop you're working on, you should be knowing about these config files. Whether you work as a Hadoop admin or you work as a Hadoop developer, knowing these config properties would be very important, and that would also showcase your internal knowledge about the configs which drive your Hadoop cluster. Let's look at the next question. So what are the three modes in which Hadoop can run? So you can have Hadoop running in a standalone mode. Now that's your default mode. It would basically use a local file system and a single Java process. So when you say standalone mode, it is as you downloading Hadoop related package on one single machine, but you would not have any process running. That would just be to test Hadoop functionalities. You could have a pseudo distributed mode, which basically means it's a single node Hadoop deployment. Now Hadoop as a framework has many services. So it has a lot of services, and those services would be running irrespective of your distribution, and each service would then have multiple processes. So your pseudo distributed mode is a mode of cluster where you would have all the important processes belonging to one or multiple services running on a single node. If you would want to work on a pseudo distributed mode and using a Cloudera, you can always go to Google and search for Cloudera's Quick Start VM. You can download it by just saying Cloudera Quick Start VM, and you can search for this, and that will allow you to download a Quick Start VM, follow the instructions, and you can have a single node Cloudera cluster running on your virtual machines. For more information, you can refer to the YouTube tutorial where I have explained about how to set up a quick start VM. Coming back, you could have finally a production setup or a fully distributed mode, which basically means that your Hadoop framework and its components would be spread across multiple machines. So you would have multiple services such as HDFS, Yarn, Flume, Sqoop, Kafka, HBase, Hive, Impala, and for these services there would be one or multiple processes distributed across multiple nodes. So this is normally what is used in production environment. So you could say standalone would be good for testing, pseudo distributed could be good for testing and development, and fully distributed would be mainly for your production setup. Now, what are the differences between regular file system and HDFS? So when you say regular file system, you could be talking about a Linux file system, or you could be talking about a Windows based operating system. So in regular file system, we would have data maintained in a single system. So the single system is where you have all your files and directories. So it is having low fault tolerance, right? So if the machine crashes, your data recovery would be very difficult unless and until you have a backup of that data. That also affects your processing. So if the machine crashes or if the machine fails, then your processing would be blocked. Now, the biggest challenge with regular file system is the seek time, the time taken to read the data. So you might have one single machine with huge amount of disks and huge amount of RAM. But then the time taken to read that data when all the data is stored in one machine would be very high, and that would be with least fault tolerance. If you talk about HDFS, your data is distributed. So HDFS stands for Hadoop Distributed File System. So here your data is distributed and maintained on multiple systems. So it is never one single machine. It is also supporting reliability. So whatever is stored in HDFS, say a file being stored, depending on its size, is split into blocks, and those blocks will be spread across multiple nodes. Not only that, every block which is stored on a node will have its replicas stored on other nodes, replication factor depends, but this makes HDFS more reliable. In cases of your slave nodes or data nodes crashing, you will rarely have data loss because of auto replication feature. Now, time taken to read the data is comparatively more, as you might have situations where your data is distributed across the nodes, and even if you are doing a parallel read, your data read might take more time because it needs coordination from multiple machines. However, if you are working with huge data which is getting stored, it will still be beneficial in comparison to reading from a single machine. So you should always think about its reliability through auto replication feature, its fault tolerance because of your data getting stored across multiple machines, and its capability to scale. So when you talk about HDFS, we are talking about horizontal scalability or scaling out. When you talk about regular file system, you are talking about vertical scalability, which is scaling up. Now, let's look at some specific HDFS questions. What is this? Why is HDFS fault tolerant? Now, as I just explained in previous slides, your HDFS is fault tolerant as it replicates data on different data nodes. So you have a master node and you have multiple slave nodes or data nodes where actually the data is getting stored. Now, we also have a default block size of 128 MB. That's the minimum since Hadoop version 2. So any file which is up to 128 MB would be using one logical block. And if the file size is bigger than 128 MB, then it will be split into blocks, and those blocks will be stored across multiple machines. Now, since these blocks are stored across multiple machines, it makes it more fault tolerant because even if your machines fail, you would still have a copy of your block existing on some other machine. Now, there are two aspects here. One, we talk about the first rule of replication, which basically means you will never have two identical blocks sitting on the same machine. And the second rule of replication is in terms of rack awareness. So if your machines are placed in racks, as we see in the right image, you will never have all the replicas placed on the same rack, even if they are on different machines. So it has to be fault tolerant and it has to maintain redundancy. So at least one replica will be placed on some other node on some other rack. That's how HDFS is fault tolerant. Now, here let's understand the architecture of HDFS. Now, as I mentioned earlier, you would in a Hadoop cluster, the main service is your HDFS. So for your HDFS service, you would have a NameNode, which is your master process running on one of the machines, and you would have data nodes, which are your slave machines getting stored across or the processes running across multiple machines. Each one of these processes has an important role to play. When you talk about HDFS, whatever data is written to HDFS, that data is split into blocks depending on its size, and the blocks are randomly distributed across nodes. With auto replication feature, these blocks are also auto replicated across multiple machines with the first condition that no two identical blocks will sit on the same machine. Now, as soon as the cluster comes up, your data nodes, which are part of the cluster and based on config files, would start sending their heartbeat to the NameNode, and this would be every 3 seconds. What does NameNode do with that? NameNode will store this information in its RAM. So NameNode starts building a metadata in its RAM, and that metadata has information of what are the data nodes which are available in the beginning. Now, when a data writing activity starts and the blocks are distributed across data nodes every 10 seconds will also send a block report to NameNode. So NameNode is again adding up this information in its RAM or the metadata in RAM, which earlier had only data node information. Now NameNode will also have information about what are the files. The files are split in which blocks, the blocks are stored on which machines, and what are the file permissions. Now, while NameNode is maintaining this metadata in RAM, NameNode is also maintaining metadata in disk. Now, that is what we see in the red box, which basically has information of whatever information was written to HDFS. So to summarize, your name node has metadata in RAM and metadata in disk. Your data nodes are the machines where your blocks or data is actually getting stored. And then there is a auto replication feature which is always existing unless and until you have disabled it. And your read and write activity is a parallel activity. However, replication is a sequential activity. Now, this is what I mentioned about when you talk about NameNode, which is the master process hosting metadata in disk and RAM. So when we talk about disk, it basically has a edit log, which is your transaction log, and your FS image, which is your file system image. Right from the time the cluster was started, this metadata in disk was existing, and this gets appended every time read, write, or any other operations happen on HDFS. Metadata in RAM is dynamically built every time the cluster comes up, which basically means that if your cluster is coming up, NameNode in the initial few seconds or few minutes would be in a safe mode, which basically means it is busy registering the information from data nodes. So NameNode is one of the most critical processes. If NameNode is down and if all other processes are running, you will not be able to access the cluster. NameNode's metadata in disk is very important for NameNode to come up and maintain the cluster. NameNode's metadata in RAM is basically for all or satisfying all your client requests. Now, when we look at data nodes, as I mentioned, data nodes hold the actual data blocks and they are sending these block reports every 10 seconds. So the metadata in NameNode's RAM is constantly getting updated. And metadata in disk is also constantly getting updated based on any kind of write activity happening on the cluster. Now, data node, which is storing the block, will also help in any kind of read activity whenever a client requests. So whenever a client or an application or an API would want to read the data, it would first talk to NameNode. NameNode would look into its metadata on RAM and confirm to the client which machines could be reached to get to that data. That's where your client would try to read the data from HDFS, which is actually getting the data from data nodes. And that's how your read-write requests are satisfied. Now, what are the two types of metadata in NameNode server holds? As I mentioned earlier, metadata in disk, very important to remember, edit log and FS image. Metadata in RAM, which is information about your data nodes. Files being split into blocks residing on data nodes, and file permissions. So I will share a very good link on this, and you can always look for more detailed information about your metadata. So you can search for HDFS metadata directories explained. Now this is from Hortonworks. However, it talks about the metadata in disk, which NameNode manages, and details about this. So have a look at this link if you are more interested in learning about metadata on disk. Coming back, let's look at the next question. What is the difference between federation and high availability? Now these are the features which were introduced in Hadoop version 2. Both of these features are about horizontal scalability of NameNode. So prior to version 2, the only possibility was that you could have one single master, which basically means that your cluster could become unavailable if NameNode would crash. So Hadoop version 2 introduced two new features, federation and high availability. However, high availability is a popular one. So when you talk about federation, it basically means any number of name nodes. So there is no limitation to the number of name nodes. Your name nodes are in a federated cluster, which basically means name nodes still belong to the same cluster, but they are not coordinating with each other. So whenever a write request comes in, one of the name node picks up that request and it guides that request for the blocks to be written on data nodes. But for this, your name node does not have to coordinate with other name node to find out if the block ID which was being assigned was the same one as assigned by other name node. So all of them belong to a federated cluster. They are linked via a cluster ID. So whenever an application or an API is trying to talk to cluster, it is always going via an cluster ID, and one of the name node would pick up the read activity or write activity or processing activity. So all the name nodes are sharing a pool of metadata in which Each name node will have its own dedicated pool, and we can remember that by a term called namespace or name service. So this also provides high fault tolerance. Suppose your one name node goes down, it will not affect or make your cluster unavailable. You will still have your cluster reachable because there are other name nodes running and they are available. Now when it comes to heartbeats, all your data nodes are sending their heartbeats to all the name nodes, and all the name nodes are aware of all the data nodes. When you talk about high availability, this is where you would only have two name nodes. So you would have an active and you would have a standby. Now normally in any environment you would see a high availability setup with Zookeeper. So Zookeeper is a centralized coordination service. So when you talk about your active and standby name nodes, election of a name node to be made as active and taking care of an automatic failover is done by your Zookeeper. High availability can be set up without Zookeeper, but that would mean that an admin's intervention would be required to make a name node as active from standby or also to take care of failover. Now, at any point of time in high availability, a active name node would be taking care of storing the edits about whatever updates are happening on HDFS, and it is also writing these edits to a shared location. Standby name node is the one which is constantly looking for these latest updates and applying to its metadata, which is actually a copy of whatever your active name node has. So in this way, your standby name node is always in sync with the active name node, and if for any reason active name node fails, your standby name node will take over and become the active. Remember, Zookeeper plays a very important role here. It's a centralized coordination service. One more thing to remember here is that in your high availability, secondary name node will not be allowed. So you would have an active name node and then you will have a standby name node which will be configured on a separate machine, and both of these will be having access to a shared location. Now that shared location could be NFS or it could be a quorum of journal nodes. So for more information, refer to the tutorial where I have explained about HDFS, high availability and federation. Now let's look at some logical question here. So if you have an input file of 350 MB, which is obviously bigger than 128 MB, how many input splits would be created by HDFS? And what would be the size of each input split? So for this, you need to remember that by default, the minimum block size is 128 MB. Now that's customizable. If your environment has more number of larger files written on an average, then obviously you have to go for a bigger block size. If your environment has a lot of files being written, but these files are of smaller size, you could be okay with 128 MB. Remember, in Hadoop, every entity, that is your directory on HDFS, file on HDFS, and a file having multiple blocks, each of these are considered as objects. And for each object, Hadoop's name node's RAM 150 bytes is utilized. So if your block size is very small, then you would have more number of blocks which would directly affect the name node's RAM. If you keep a block size very high, that will reduce the number of blocks, but remember that might affect in processing because processing also depends on splits. More number of splits, more the parallel processing. So setting of block size has to be done with consideration about your parallelism requirement and your name node's RAM which is available. Now coming to the question, if you have a file of 350 MB, that would be split into 3 blocks, and here 2 blocks would have 128 MB data, and the third block, although the block size would still be 128, it would have only 94 MB of data. So this would be the split of this particular file. Now let's understand about rack awareness. How does rack awareness work? Or why do we even have racks? So organizations always would want to place their nodes or machines in a systematic way. There can be different approaches. You could have a rack which would have machines running on the master processes, and the intention would be that this particular rack could have higher bandwidth, more cooling, dedicated power supply, top of rack switch, and so on. The second approach could be that you could have one master process running on one machine of every rack, and then you could have other slave processes running. Now, When you talk about your rack awareness, one thing to understand is that if your machines are placed within racks, and we are aware that Hadoop follows auto replication, the rule of replication in a rack aware cluster would be that you would never have all the replicas placed on the same rack. So if we look at this, if we have block A in blue color, you will never have all the three blue boxes in the same rack, even if they are on different nodes, because that makes it less fault tolerant. So you would have at least one copy of block which would be stored on a different rack on a different node. Now let's look at this. So basically here we are talking about replicas being placed in such a way. Now somebody could ask a question, can I have my block and its replicas spread across 3 racks? And yes, you can do that, but then in order to make it more redundant, you are increasing your bandwidth requirement. So the better approach would be 2 blocks on the same rack on different machines and 1 copy on a different rack. Now let's proceed. How can you restart NameNode and all daemons in Hadoop? So if you were working on an Apache Hadoop cluster, then you could be doing a start and stop using Hadoop daemon scripts. So there are these Hadoop daemon scripts which would be used to start and stop your Hadoop. And this is when you talk about your Apache Hadoop. So let's look at one particular file which I would like to show you more information here. And this talks about your different clusters. So let's look into this, and so let's look at the start and stop. And here I have a file. Let's look at this one, and this gives you highlights. So if you talk about Apache Hadoop, this is how the setup would be done. So you would have it download the Hadoop tar file, you would have to untar it, edit the config files, you would have to do formatting, and then start your cluster. And here I have said using scripts. So this is in case of Apache Hadoop, you could be using a start all script that internally triggers start DFS and start yarn. And these scripts, start DFS, internally would run Hadoop daemon multiple times based on your configs to start your different processes. Then your start yarn would run yarn daemon script to start your processing related processes. So this is how it happens in Apache Hadoop. Now in case of Cloudera or Hortonworks, which is basically a vendor specific distribution, you would have say multiple services which would have one or multiple daemons running across the machines. Let's take an example here that you would have machine 1, machine 2 and machine 3 with your processes spread across. However, in case of Cloudera and Hortonworks, these are cluster management solutions. So you would never be involved in running a script individually to start and stop your processes. In fact, in case of Cloudera, you would have a Cloudera SCM server running on one of the machines and then Cloudera SCM agents running on every machine. If you talk about Hortonworks, you would have Ambari server and Ambari agent running. So your agents which are running on every machine are responsible to monitor the processes, send also their heartbeat to the master, that is your server, and your server is the one or a service which basically will give instructions to the agents. So in case of vendor specific distribution, your start and stop of processes is automatically taken care by these underlying services, and these services internally are still running these commands. However, only in Apache Hadoop you have to manually follow these to start and stop. Coming back, we can look into some command related questions. So which command will help you find the status of blocks and file system health? So you can always go for a file system check command. Now that can show you the files for a particular HDFS path. It can show you the blocks, and it can also give you information on status such as under replicated blocks, over replicated blocks, misreplicated blocks, default replication, and so on. So your FSCK file system check utility does not repair if there is any problem with the blocks, but it can give you information of blocks related to the files, on which machines they are stored, if they are replicated as per the replication factor, or if there is any problem with any particular replica. Now, what would happen if you store too many small files in a cluster? And this relates to the block information which I gave some time back. So remember, Hadoop is coded in Java. So here every directory, every file and file related block is considered as an object. And for every object within your Hadoop cluster, NameNode's RAM gets utilized. So more number of blocks you have, more would be usage of NameNode's RAM. And if you're storing too many small files, it would not affect your disk. It would directly affect your NameNode's RAM. That's why in production clusters, admin guys or infrastructure specialists will take care that everyone who is writing data to HDFS follows a quota system so that you could be controlled in the amount of data you write plus the count of data an individual writes on HDFS. Now, how do you copy data from local system onto HDFS? So you can use a put command or a copy from local and then give in your local path, which is your source, and then your destination, which is your HDFS path. Remember, you can always do a copy from local using a -f option. That's a flag option, and that also helps you in writing the same file or a new file to HDFS. So with your -f, you have a chance of overwriting or rewriting the data which is existing on HDFS. So copy from local or -put. Both of them do the same thing, and you can also pass an argument when you're copying to control your replication or other aspects of your file. Now, when do you use DFS admin refresh nodes or RM admin refresh nodes? So as the command says, this is basically to do with refreshing the node information. So your refresh nodes is mainly used when, say, a commissioning or decommissioning of nodes is done. So when a node is added into the cluster or when a node is removed from the cluster, you are actually informing Hadoop master that this particular node would not be used for storage and would not be used for processing. Now in that case, you would be, once you are done with the process of commissioning or decommissioning, you would be giving these commands, that is refresh nodes and RM admin refresh nodes. So internally, when you talk about commissioning, decommissioning, there are include and exclude files which are updated. And these include and exclude files will have entry of machines which are being added to the cluster or machines which are being removed from the cluster. And while this is being done, the cluster is still running. So you do not have to restart your master process. However, you can just use these refresh commands to take care of your commissioning, decommissioning activities. Now, is there any way to change replication of files on HDFS after they are already written? And the answer is, of course, yes. So if you would want to set a replication factor at a cluster level, and if you have admin access, then you could edit your HDFS-site file, or you could say Hadoop-site file. And that would take care of replication factor being set at a cluster level. However, if you would want to change the replication after the data has been written, you could always use a setrep command. So setrep command is basically to change the replication after the data is written. You could also write the data with a different replication, and for that you could use a -d dfs.replication and give your replication factor when you are writing data to the cluster. So in Hadoop, you can let your data be replicated as per the property set in the config file. You could write the data with a different replication. You could change the replication after the data is written. So all these options are available. Now, who takes care of replication consistency in a Hadoop cluster? And what do you mean by under, over replicated blocks? Now, as I mentioned, your fsck command can give you information of over or under replicated blocks. Now, in a cluster, it is always and always NameNode which takes care of replication consistency. So for example, if you have set up a replication of 3, and since we know the first rule of replication, which basically means that you cannot have 2 replicas residing on the same node, it would mean that if your replication is 3, we would need at least 3 data nodes available. Now say for example, you had a cluster with 3 nodes and replication was set to 3. At one point of time, one of your name node crashed. And if that happens, your blocks would be under replicated. That means there was a replication factor set, but now your blocks are not replicated, or there are not enough replicas as per the replication factor set. This is not a problem. Your master process or NameNode will wait for some time before it will start the replication of data again. So if a data node is not responding, or if a disk has crashed, and if NameNode does not get information of a replica, NameNode will wait for some time and then it will start re-replication of those missing blocks from the available nodes. However, while NameNode is doing it, the blocks are in under-replicated situation. Now, when you talk about over-replicated, this is a situation where NameNode realizes that there are extra copies of block. Now, this might be the case that you had 3 nodes running with a replication of 3. One of the node went down due to a network failure or some other issue. Within few minutes, NameNode re-replicated the data, and then the failed node is back with its set of blocks. Again, NameNode is smart enough to understand that this is an over replication situation, and it will delete set of blocks from one of the nodes. It might be the node which has been recently added, it might be your old node which has joined your cluster again, or any node. That depends on the load on a particular node. Now, we discussed about Hadoop, we discussed about HDFS. Now we will discuss about MapReduce, which is the programming model, and you can say processing framework. What is distributed cache in MapReduce? Now we know that when we talk about MapReduce, the data which has to be processed might be existing on multiple nodes. So when you would have your MapReduce program running, it would basically read the data from the underlying disks. Now this could be a costly operation if every time the data has to be read from disk. So distributed cache is a mechanism wherein data set or data which is coming from the disk can be cached and available for all worker nodes. Now how will this benefit? So when a MapReduce is running, instead of every time reading the data from disk, it would pick up the data from distributed cache, and this will benefit your MapReduce processing. So distributed cache can be set in your job conf, where you can specify that a file should be picked up from distributed cache. Now let's understand about these roles. So what is a record reader, what is a combiner, what is a partitioner, and what kind of roles do they play in a MapReduce processing paradigm or MapReduce operation. So record reader communicates with the input split, and it basically converts the data into key value pairs. And these key value pairs are the ones which will be worked upon by the mapper. Your combiner is an optional phase. It's like a mini reduce. So combiner does not have its own class. It relies on the reducer class. Basically, your combiner would receive the data from your map tasks which would have completed, works on it based on whatever reducer class mentions, and then passes its output to the reducer phase. Partitioner is basically a phase which decides how many reduce tasks would be used, aggregate or summarize your data. So partitioner is a phase which would decide based on the number of keys, based on the number of map tasks. Your partitioner would decide if one or multiple reduce tasks would be used to take care of processing. So either it could be partitioner which decides on how many reduce tasks would run, or it could be based on the properties which we have set within the cluster, which will take care of the number of reduce tasks which would be used. Always remember, your partitioner decides how outputs from combiner are sent to reducer and to how many reducers. It controls the partitioning of keys of your intermediate map outputs. So map phase, whatever output it generates is an intermediate output, and that has to be taken by your partitioner or by a combiner and then partitioner to be sent to one or multiple reduce tasks. This is one of the common questions which you might face. Why is MapReduce slower in processing? So we know MapReduce goes for parallel processing. We know we can have multiple map tasks running on multiple nodes at the same time. We also know that multiple reduce tasks could be running. Now why does then MapReduce become a slower approach? First of all, your MapReduce is a batch oriented operation. Now, MapReduce is very rigid and it strictly uses mapping and reducing phases. So no matter what kind of processing you would want to do, you would have to still provide the mapper function and the reducer function to work on data. Not only this, whenever your map phase completes, the output of your map phase, which is an intermittent output, would be written to HDFS and thereafter underlying disks. And this data would then be shuffled and sorted and picked up for reducing phase. So every time your data being written to HDFS and retrieved from HDFS makes MapReduce a slower approach. The question is, for a MapReduce job, is it possible to change the number of mappers to be created? Now, by default, you cannot change the number of map tasks because number of map tasks depends on the input splits. However, there are different ways in which you can either set a property to have more number of map tasks which can be used, or you can customize your code or make it use a different format which can then control the number of map tasks. By default, number of map tasks are equal to the number of splits of file you are processing. So if you have a 1 GB of file that is split into 8 blocks of 128 MB, there would be 8 map tasks running on the cluster. These map tasks are basically running your mapper function. If you have hard-coded properties in your mapred-site file to specify more number of map tasks, then you could control the number of map tasks. Let's also talk about some data types. So when you prepare for Hadoop, when you want to get into big data field, you should start learning about different data formats. Now there are different data formats such as Avro, Parquet, you have sequence file or binary format, and these are different formats which are used. Now when you talk about your data types in Hadoop, these are implementation of your writable and writable comparable interfaces. So for every data type in Java, you have a equivalent in Hadoop. So int in Java would be int writable in Hadoop, float would be float writable, long would be long writable, double writable, boolean writable, array writable, map writable, and object writable. So these are your different data types that could be used within your MapReduce program. And these are implementation of writable and writable comparable interfaces. What is speculative execution? Now imagine you have a cluster which has huge number of nodes and your data is spread across multiple slave machines or multiple nodes. Now at a point of time, due to a disk degrade or network issues or machine heating up or more load being on a particular node, there can be a situation where your data node will execute task in a slower manner. Now in this case, if speculative execution is turned on, there would be a shadow task or another similar task running on some other node for the same processing. So whichever task finishes first will be accepted and the other task would be killed. So speculative execution could be good if you are working in an intensive workload kind of environment, where if a particular node is slower, you could benefit from a unoccupied or a node which has less load to take care of your processing. Going further, this is how we can understand. So node A, which might be having a slower task, you would have a scheduler which is maintaining or having knowledge of what are the resources available. So if speculative execution as a property is turned on, then the task which was running slow, a copy of that task, or you can say a shadow task, would run on some other node, and whichever task completes first will be considered. This is what happens in your speculative execution. Now, how is identity mapper different from chain mapper? Now this is where we are getting deeper into MapReduce concepts. So when you talk about mapper, identity mapper is the default mapper which is chosen when no mapper is specified in MapReduce driver class. So for every MapReduce program, you would have a map class which is taking care of your mapping phase, which basically has a mapper function and which would run one or multiple map tasks, right? Your program would also have a reduce class, which would be running a reducer function, which takes care of reduce tasks running on multiple nodes. Now, if a mapper is not specified within your driver class, so driver class is something which has all information about your flow. What's your map class? What is your reduce class? What's your input format? What's your output format? What are the job configurations and so on? So identity mapper is the default mapper which is chosen when no mapper class is mentioned in your driver class. It basically implements an identity function which directly writes all its key pairs into output. And it was defined in old MapReduce API in this particular package. But when you talk about chaining mappers or chain mapper, this is basically a class to run multiple mappers in a single map task. Or basically you could say multiple map tasks would run as a part of your processing. The output of first mapper would become as an input to second mapper and so on. And this can be defined in the undermentioned class or package. What are the major configuration parameters required in a MapReduce program? Obviously, we need to have the input location. We need to have the output location. So input location is where the files will be picked up from, and this would preferably on HDFS directory. Output location is the path where your job output would be written by your MapReduce program. You also need to specify input and output formats. If you don't specify, the defaults are considered. Then we need to also have the classes which have your map and reduce functions. And if you intend to run the code on a cluster, you need to package your class in a jar file, export it to your cluster, and then this jar file would have your mapper, reducer, and driver classes. So these are important configuration parameters which you need to consider for a MapReduce program. Now, what is the difference, or what do you mean by map side join and reduce side join? Map side join is basically when the join is performed at the mapping level or at the mapping phase, or is performed by the mapper. So each input data which is being worked upon has to be divided into same number of partitions. Input to each map is in the form of a structured partition and is in sorted order. So map side join, you can understand it in a simpler way that if you compare it with RDBMS concepts where you had two tables which were being joined, it will always be advisable to give your bigger table as the left side table or the first table for your join condition, and it would be your smaller table on the left side and your bigger table on the right side, which basically means the smaller table could be loaded in memory and could be used for joining. So map side join is a similar kind of mechanism where input data is divided into same number of partitions. When you talk about reduce side join, here the join is performed by the reducer. So it is easier to implement than map side join, as all the sorting and shuffling will send the values or send all the values having identical keys to the same reducer. So you don't need to have your data set in a structured form. So look into your map side join or reduce side join and other joins just to understand how MapReduce works. However, I would suggest not to focus more on this because MapReduce is still being used for processing, but the amount of MapReduce based processing has decreased overall or across the industry. Now, what is the role of output committer class in a MapReduce job? So output committer, as the name says, describes the commit of task output for a MapReduce job. So we could have this as mentioned, org Apache Hadoop MapReduce output committer. You could have a class which extends your output committer class. So MapReduce relies on this. MapReduce relies on the output committer of the job to set up the job initialization, cleaning up the job after the job completion. That means all the resources which were being used by a particular job, setting up the task temporary output, checking whether a task needs a commit, committing the task output, and discarding the task out. So this is a very important class and can be used within your MapReduce job. What is the process of spilling in MapReduce? What does that mean? So spilling is basically a process of copying the data from memory buffer to disk when obviously the buffer usage reaches a certain threshold. So if there is not enough memory in your buffer, in your memory, then the content which is stored in buffer or memory has to be flushed out. So by default, a background thread starts spilling the content from memory to disk after 80% of buffer size is filled. Now when is the buffer being used? So when your MapReduce processing is happening, the data is being read from the disk, loaded into the buffer, and then some processing happens. Same thing also happens when you are writing data to the cluster. So you can imagine for a 100 megabyte size buffer, the spilling will start after the content of buffer reaches 80 megabytes. This is customizable. How can you set the mappers and reducers for a MapReduce job? So these are the properties. So number of mappers and reducers, as I mentioned earlier, can be customized. So by default, your number of map tasks depends on the split, and number of reduced tasks depends on the partitioning phase, which decides number of reduced tasks which would be used depending on the keys. However, we can set these properties either in the config files or provide them on the command line, or also make them part of our code, and this can control the number of map tasks or reduced tasks which would be run for a particular job. Let's look at one more interesting question. What happens when a node running a map task fails before sending the output to the reducer? So there was a node which was running a map task, and we know that there could be one or multiple map tasks running on one or multiple nodes, and all the map tasks have to be completed before the further stages that such as combiner or reducer come into existence. So in a case if a node crashes where a map task was assigned to it, the whole task will have to be run again on some other node. So in Hadoop version 2, Yarn framework has a temporary daemon called application master. So your application master is taking care of execution of your application. And if a particular task on a particular node failed due to unavailability of node, it is the role of application master to have this task scheduled on some other node. Now, can we write the output of MapReduce in different formats? Of course we can. So Hadoop supports various input and output formats. So you can write the output of MapReduce in different formats. So you could have the default format, that is text output format, wherein records are written as line of text. You could have sequence file, which is basically to write sequence files or your binary format files, where your output files need to be fed into another MapReduce jobs. You could go for a map file output format to write output as map files. You could go for a sequence file as a binary output format. So that's again a variant of your sequence file input format. It basically writes keys and values to a sequence file. So when we talk about binary format, we are talking about a non-human readable format. DB output format. Now this is basically used when you would want to write data to say relational databases or say NoSQL databases such as HBase. So this format also sends the reduce output to a SQL table. Now let's learn a little bit about Yarn. Yarn, which stands for yet another resource negotiator. It's the processing framework. So what benefits did Yarn bring in Hadoop version 2, and how did it solve the issues of MapReduce version 1? So MapReduce version 1 had major issues when it comes to scalability or availability because, in Hadoop version 1, you had only one master process for processing layer, and that is your job tracker. So your job tracker was listening to all the task trackers which were running on multiple machines. So your job tracker was responsible for resource tracking and job scheduling. In Yarn, you still have a processing master, but that's called resource manager instead of job tracker. And now with Hadoop version 2, you could even have resource manager running in high availability mode. You have node managers which would be running on multiple machines, and then you have a temporary daemon called application master. So in case of Hadoop version 2, your resource manager or master is only handling the client connections and taking care of tracking the resources. The jobs scheduling or basically taking care of execution across multiple nodes is controlled by application master till the application completes. So in Yarn, you can have different kind of resource allocations that could be done, and there is a concept of container. So container is basically a combination of RAM and CPU cores. Yarn can run different kind of workloads. So it is not just MapReduce kind of workload which can be run on Hadoop version 2, but you could have graph processing, massive parallel processing, you could have real-time processing, and huge processing applications could run on a cluster based on Yarn. So when we talk about scalability, in case of your Hadoop version 2, you can have a cluster size of more than 10,000 nodes and can run more than 100,000 concurrent tasks. And this is because for every application which is launched, you have this temporary daemon called application master. So if I would have 10 applications running, I would have 10 app masters running, taking care of execution of these applications across multiple nodes. Compatibility. So Hadoop version 2 is fully compatible with whatever was developed as per Hadoop version 1, and all your processing needs would be taken care by Yarn. So dynamic allocation of cluster resources, taking care of different workloads, allocating resources across multiple machines and using them for execution, all that is taken care by Yarn. Multi-tenancy, which basically means you could have multiple users or multiple teams. You could have open source and proprietary data access engines, and all of these could be basically hosted using the same cluster. Now, how does Yarn allocate resources to an application with the help of its architecture? So basically, you have a client or an application or an API which talks to resource manager. Resource manager is, as I mentioned, managing the resource allocation in the cluster. When you talk about resource manager, you have its internal two components. One is your scheduler and one is your applications manager. So when we say resource manager being the master is tracking the resources, resource manager is the one which is negotiating the resources with slave. It is not actually resource manager who is doing it, but these internal components. So you have a scheduler which allocates resources to various running applications. So scheduler is not bothered about tracking your resources or basically tracking your applications. So we can have different kind of schedulers such as FIFO, which is first in first out. You could have a fair scheduler or you could have a capacity scheduler. And these schedulers basically control how resources are allocated to multiple applications when they are running in parallel. So there is a queue mechanism. So scheduler will schedule resources based on requirements of application, but it is not monitoring or tracking the status of applications. Your applications manager is the one which is accepting the job submissions. It is monitoring and restarting the application masters. So it's application manager which is basically then launching a application master which is responsible for an application. So this is how it looks. So whenever a job submission happens, we already know that resource manager is aware of the resources which are available with every node manager. So on every node which has fixed amount of RAM and CPU cores, some portion of resources, that is your RAM and CPU cores, are allocated to node manager. Now resource manager is already aware of how much resources are available across nodes. So whenever a client request comes in, resource manager will make a request to node manager. It will basically request node manager to hold some resources for processing. Node manager would basically approve or disapprove this request of holding resources. And these resources, that is a combination of RAM and CPU cores, are nothing but containers. We can allocate containers of different sizes within yarn-site file. So your node manager, based on a request from resource manager, guarantees the container which would be available for processing. That's when your resource manager starts a temporary daemon called application master to take care of your execution. So your app master, which was launched by resource manager, or we can say internally by applications manager, will run in one of the containers, because application master is also a piece of code. So it will run in one of the containers, and then other containers will be utilized for execution. This is how Yarn is basically taking care of your allocation. Your application master is managing resource needs. It is the one which is interacting with scheduler, and if a particular node crashes, it is the responsibility of app master to go back to the master, which is resource manager, and negotiate for more resources. So your app master will never ever negotiate resources with node manager directly. It will always talk to resource manager, and resource manager is the one which negotiates the resources. Container, as I said, is a collection of resources like your RAM, CPU, network bandwidth, and your container is allocated based on the availability of resources on a particular node. So, which of the following has occupied the place of a job tracker of MapReduce? So it is your resource manager. So resource manager is the name of the master process in Hadoop version 2. Now, if we would have to write yarn commands to check the status of an application, so we could just say yarn application minus status and then the application ID. And you could kill it also from the command line. Remember, your yarn has a UI, and you can even look at your applications from the UI. You can even kill your applications from the UI. However, knowing the command line commands would be very useful. Can we have more than one resource manager in a yarn based cluster? Yes, we can. That is what Hadoop version 2 allows us to have. So you can have a high availability yarn cluster where you have an active and standby, and the coordination is taken care by your Zookeeper. At a particular time, there can only be one active resource manager, and if active resource manager fails, your standby resource manager comes and becomes active. However, Zookeeper is playing a very important role. Remember, Zookeeper is the one which is coordinating the server state, and it is doing the election of active to standby failover. What are the different schedulers available in Yarn? So you have a FIFO scheduler, that is first in, first out, and this is not a desirable option, because in this case, a longer running application might block all other small running applications. Your capacity scheduler is basically a scheduler where dedicated queues are created and they have fixed amount of resources. So you can have multiple applications accessing the cluster at the same time, and they would be using their own queues and the resources allocated to them. If you talk about fair scheduler, you don't need to have a fixed amount of resources. You can just have a percentage, and you could decide what kind of fairness is to be followed, which basically means that if you were allocated 20 gigabytes of memory, however, the cluster has 100 gigabytes, and the other team was assigned 80 gigabytes of memory, then you have 20% access to the cluster, another team has 80%. However, if the other team does not come up or does not use the cluster, in a fair scheduler, you can go up to maximum of 100% of your cluster. To find out more information about your schedulers, you could either look in Hadoop definitive guide, or what you could do is you could just go to Google and you could type, for example, yarn scheduler. Let's search for yarn scheduler, and then you can look in Hadoop definitive guide. And so this is your Hadoop definitive guide, and it beautifully explains about your different schedulers, how do multiple applications run, and that could be in your FIFO kind of scheduling, it could be in capacity scheduler, or it could be in a fair scheduling. So have a look at this link. It's a very good link. You can also search for yarn untangling, and this is a blog of this is a series of 4 blogs where it's beautifully explained about your yarn, how it works, how the resource allocation happens, what is a container, and what runs within the container. So you can scroll down, you can be reading through this, and you can then also search for part 2 of it, which talks about allocation and so on. So coming back, we basically have these schedulers. What happens if a resource manager fails while executing an application in a high availability cluster? So in a high availability cluster, we know that we would have two resource managers, one being active, one being standby, and Zookeeper, which is keeping a track of the server states. So if a RM fails in case of high availability, the standby will be elected as active, and then basically your resource manager or the standby would become the active one. And this one would instruct the application master to abort in the beginning. Then your resource manager recovers its running state. So there is something called as RM state store, where all the applications which are running, their status is stored. So resource manager recovers its running state by looking at your state store, by taking advantage of container statuses, and then continues to take care of your processing. Now, in a cluster of 10 data nodes, each having 16 GB and 10 cores, what would be total processing capacity of the cluster? Take a minute to think. 10 data nodes, 16 GB RAM per node, 10 cores. So, if you mention the answer as 160 GB RAM and 100 cores, then you went wrong. Now think of a cluster which has 10 data nodes, each having 16 GB RAM and 10 cores. Remember, on every node in a Hadoop cluster, you would have one or multiple processes running. Those processes would need RAM. The machine itself, which has a Linux file system, would have its own processes. So that would also be having some RAM usage, which basically means that if you talk about 10 data nodes, you should deduct at least 20 to 30% towards the overheads, towards the Cloudera based services, towards the other processes which are running. And in that case, I could say that you could have 11 or 12 GB available on every machine for processing, and say 6 or 7 cores. Multiply that by 10, and that's your processing capacity. Remember, the same thing applies to the disk usage also. So if somebody asks you, in a 10 data node cluster where each machine has 20 terabytes of disks, what is my total storage capacity available for HDFS? So the answer would not be 200. You have to consider the overheads. And this is basically which gives you your processing capacity. Now let's look at one more question. So what happens if requested memory or CPU cores beyond or goes beyond the size of container? Now, as I said, you can have your configurations which can say that in a particular data node which has 100 GB RAM, I could allocate say 50 GB for the processing. Out of 100 cores, I could say 50 cores for processing. So if you have 100 GB RAM and 100 cores, you could ideally allocate 100 for processing, but that's not ideally possible. So if you have 100 GB RAM, you would go for 50 GB. And if you have 100 cores, you would go for 50 cores. Now, within this RAM and CPU cores, you have the concept of containers, right? So container is a combination of RAM and CPU cores. So you could have a minimum size container and maximum size container. Now, at any point of time, if your application starts demanding more memory or more CPU cores, and this cannot fit into a container allocation, your application will fail. Your application will fail because you requested for a memory or a combination of memory and CPU cores which is more than the maximum container size. So look into this yarn tangling website which I mentioned, and look for the second blog in those series which explains about these allocations. Now here we will discuss on Hive, Pig, HBase, and these components of Hadoop which are being used in the industry for various use cases. Let's look at some questions here and let's look how you should prepare for them. So first of all, we will learn on Hive, which is a data warehousing package. So the question is, what are the different components of a Hive architecture? Now, when we talk about Hive, we already know that Hive is a data warehousing package, which basically allows you to work on structured data or data which can be structurized. So normally people are well versed with querying or basically processing the data using SQL queries. A lot of people come from database backgrounds and they would find it comfortable if they know structured query language. Hive is one of the data warehousing package which resides within a Hadoop ecosystem. It uses Hadoop's distributed file system to store the data, and it uses RDBMS usually to store the metadata, although metadata can be stored locally also. So what are the different components of an Hive architecture? So it has a user interface. So user interface calls the execute interface to the driver. This creates a session to the query, and then it sends the query to the compiler to generate an execution plan for it. Usually, whenever Hive is set up, it would have its metadata stored in an RDBMS. Now, to establish the connection between RDBMS and Hadoop, we need ODBC or JDBC connector jar file, and that connector jar file has a driver class. Now this driver class is mandatory to create a connection between Hive and Hadoop. So user interface creates this interface using the driver. Now we have metastore. Metastore stores the metadata information. So any object which you create, such as database, table, indexes, their metadata is stored in metastore, and usually this metastore is stored in an RDBMS so that multiple users can connect to Hive. So your metastore stores the metadata information and sends that to the compiler for execution of a query. What does the compiler do? It generates the execution plan. It has a DAG. Now DAG stands for direct acyclic graph. So it has a DAG of stages where each stage is either a metadata operation, a MapReduce job, or an operation on HDFS. And finally, we have execution engine that acts as a bridge between Hive and Hadoop to process the query. So execution engine communicates bidirectionally with metastore to perform operations like create or drop tables. So these are 4 important components of Hive architecture. Now, what is the difference between external table and managed table in Hive? So we have various kinds of table in Hive, such as external table, managed table, partition table. The major difference between your managed and external table is in respect to what happens to the data if the table is dropped. Usually whenever we create a table in Hive, it creates a managed table, or we could also call that as an internal table. Now this manages the data and moves it into warehouse directory by default. Whether you create a managed table or external table, usually the data can reside in Hive's default warehouse directory, or it could be residing in a location chosen. However, when we talk about managed table, if one drops a managed table, not only the metadata information is deleted, but the table's data is also deleted from HDFS. If we talk about external table, it is created with an external keyword explicitly, and if an external table is dropped, nothing happens to the data which resides in HDFS. So that's the main difference between your managed and external table. What might be the use case if somebody asks you? There might be a migration kind of activity, or you are interested in creating a lot of tables using your queries. So in that case, you could dump all the data on HDFS, and then you could create a table by pointing to a particular directory or multiple directories. Now you could then do some testing of your tables and would decide that you might not need all the tables. So in that case, it would be advisable to create external tables so that even if the table is later dropped, the data on HDFS will be intact, unlike your managed table where dropping of table will delete the data from HDFS also. Let's learn a little bit on partition. So what is partition in Hive and why is partitioning required in Hive? If somebody asks you that. Now, normally in world of RDBMS, partition is the process to group similar type of data together. And that is usually done on basis of a column or what we call as partitioning key. Now, each table usually has one column in context of RDBMS, which could be used to partition the data. And why do we do that? So that we can avoid scanning the complete table for a query and restrict the scan to set of data or to a particular partition. In Hive, we can have any number of partition keys. So partitioning provides granularity in Hive table. It reduces the query latency by scanning only relevant partition data instead of whole data set. We can partition at various levels. Now, if I compare RDBMS with Hive, in case of RDBMS, you could have one column which could be used for partitioning, and then you could be querying the specific partition. So in case of RDBMS, your partition column is usually a part of the table definition. So for example, if I have an employee table, I might have employee ID, employee name, employee age, and employee salary as 4 columns, and I would decide to partition the table based on salary column. Now, why would I partition it? Because I feel that employee table is growing very fast. It is, or it will have huge amount of data. And later when we query the table, we don't want to scan the complete table. So I could split my data into multiple partition based on a salary column giving some ranges. In Hive, it is a little different. In Hive, you can do partitioning, and there is a concept of static and dynamic partitioning. But in Hive, the partition column is not part of table definition. So you might have an employee table with employee ID, name, age, and that's it. That would be the table definition. But you could then have partitioning done based on salary column, which will then create a specific folder on HDFS. In that case, when we query the data, we can see the partition column also showing up. So we can partition the transaction data for a bank, for example, based on month like Jan, Feb, etc. And any operation regarding a particular month will then allow us to query that particular folder. That is where partitioning is useful. Now, why does Hive not store metadata information in HDFS if somebody asks you? So we know that Hive's data is stored in HDFS, which is Hadoop distributed file system. However, the metadata is either stored locally, and that mode of Hive would be called as embedded mode, or you could have Hive's metadata stored in RDBMS so that multiple clients can initiate a connection. Now this metadata, which is very important for Hive, would not be stored in HDFS. So we already know that HDFS read and write operations are time consuming. It is a distributed file system and it can accommodate huge amount of data. So Hive stores metadata information in metastore using RDBMS instead of HDFS. So this allows to achieve low latency and faster data access. Now, if somebody asks, what are the components used in Hive query processor? So usually we have the main components are your parser, your execution engine, logical plan generation, optimizer, and type checking. So whenever a query is submitted, it will go through a parser, and parser would check the syntax, it would check for objects which are being queried and other things to see if the query is fine. Now internally you have a semantic analyzer which will also look at the query. You have an execution engine which basically will work on the execution part. That is the best generated execution plan which could be used to get the results for the query. You could also have user-defined functions which a user would want to use, and these are normally created in Java or Java programming language, and then basically these user-defined functions are added to the class path. Now you would have a logical plan generation which basically looks at your query and then generates a logical plan or the best execution path which would be required to get to the results. Internally, there is a physical plan generated, which is then looked in by optimizer to get the best path to get to the data. And that might also be checking your different operators which you are using within your query. Finally, we would also have type checking. So these are important components in Hive. So somebody might ask you, if you are querying your data using Hive, what are the different components involved? Or if you could explain what are the different components which work when a query is submitted. So these are the components. Now let's look a scenario-based question. Suppose there are a lot of small CSV files which are present in a HDFS directory, and you want to create a single Hive table from these files. So data in these files have fields like registration number, name, email, address. So if this is what needs to be done. What will be your approach to solve it? Where will you create a single Hive table for lots of small files without degrading the performance of the system? So there can be different approaches. Now we know that there are a lot of small CSV files which are present in a directory. So we know that when we create a table in Hive, we can use a location parameter. So I could say create table, give a table name, give the column and their data types. I could specify the delimiters, and finally I could say location and then point it to a directory on HDFS. And this directory might be the directory which has a lot of CSV files. So in this case, I will avoid loading the data in the table, because table pointing to the directory will directly pick up the data from one or multiple files. And we also know that Hive does schema check on read. So it does not do a schema check on write. So in case there were one or two files which did not follow the schema of the table, it would not prevent data loading. Data would anyways be loaded. Only when you query the data, it might show you null values if data which was loaded does not follow the schema of the table. This is one approach. What is the other approach? So let's look at that. You can think about sequence file format, which is basically a smart format or a binary format, and you can group these small files together to form a sequence file. Now this could be one other smarter approach. So we could create a temporary table. So we could say create table, give a table name, give the column names and their data types. We could specify the delimiters as it shows here, that is row format, and fields terminated by, and finally we can store that as text file. Then we can load data into this table by giving a local file system path, and then we can create a table that will store data in sequence file format. So my point 1 is storing the data in text file. Point 3 would be storing the data in sequence file format. So we say create table, give the specifications, we say row format delimited, fields are terminated by comma, stored as sequence file. Then we can move the data from test table into test sequence file table. So I could just say insert overwrite my new table as select star from other table. Remember, in Hive you cannot do insert, update, delete. However, if the table is existing, you can do a insert overwrite from an existing table into a new table. So this could be one approach where we could have a lot of CSV files or smaller files clubbed together as one big sequence file and then store it in the table. Now, if somebody asks you, write a query to insert a new column, that is integer data type, into a Hive table, and the requirement might be that you would want to insert this table at a position before an existing column. Now that's possible by doing an alter table, giving your table name, and then specifying change column, giving your new column with the data type before an existing column. This is a simple way wherein you can insert a new column into a Hive table. What are the key differences between Hive and Pig? Now, some of you might have heard Hive is a data warehousing package and Pig is more of a scripting language. Both of them are used for data analysis, trend detection, hypothesis testing, data transformation, and many other use cases. So if we compare Hive and Pig, Hive uses a declarative language called HiveQL, that is Hive querying language, similar to SQL, and it is for reporting or for data analysis, even for data transformation or for your data extraction. Pig uses a high-level procedural language called Pig Latin for programming. Both of them, remember, use MapReduce processing framework. So when we run a query in Hive to process the data, or when we create and submit a Pig script, both of them trigger a MapReduce job unless and until we have set them to local mode. Hive operates on the server side of the cluster and basically works on structured data or data which can be structurized. Pig usually works or operates on the client side of the cluster and allows both structured, unstructured, or even I could say semi-structured data. Hive does not support Avro file format by default. However, that can be done by using the write serializer deserializer. So we can have Hive table related data stored in Avro format, in sequence file format, in Parquet format, or even as a text file format. However, when we are working on smarter formats like Avro or sequence file or Parquet, we might have to use specific serializers, deserializers. For Avro, this is the package which allows us to use Avro format. Pig supports Avro format by default. Hive was developed by Facebook and it supports partitioning, and Pig was developed by Yahoo and it does not support partitioning. So these are high level differences. There are lots and lots of differences. Remember, Hive is more of a data warehousing package and Pig is more of a scripting language or a strictly procedural flow following scripting language which allows us to process the data. Now let's get more deeper and learn about Pig, which is, as I mentioned, a scripting language which can be used for your data processing. It also uses MapReduce, although we can even have Pig run in a local mode. Let's learn about Pig in the next section. Now let's learn on some questions about Pig, which is a scripting language and it is extensively used for data processing and data analysis. So the question is, how is Apache Pig different from MapReduce? Now we all know that MapReduce is a programming model. It's quite rigid when it comes to processing the data because you have to do the mapping and reducing. You have to write huge code. Usually MapReduce is written in Java, but now it can also be written in Python. It can be written in Scala and other programming languages. So if we compare Pig with MapReduce, Pig obviously is very concise. It has less lines of code when compared to MapReduce. Now, we also know that Pig script internally will trigger a MapReduce job. However, user need not know about MapReduce programming model. They can simply write simple scripts in Pig and that will automatically be converted into MapReduce. However, MapReduce has more lines of code. Pig is high-level language which can easily perform join operations or other data processing operations. MapReduce is a low-level language which cannot perform join operations easily. So we can do join using MapReduce. However, it's not really easy in comparison to Pig. Now, as I said, on execution, every Pig operator is converted internally into a MapReduce job. So every Pig script which is run, which would be converted into MapReduce job. Now MapReduce overall is a batch oriented processing, so it takes more time to compile, it takes more time to execute, either when you run a MapReduce job or when it is triggered by Pig script. Pig works with all versions of Hadoop, and when we talk about MapReduce program, which is written in one Hadoop version, may not work with other versions. It might work or it might not. It depends on what are the dependencies, what is the compiler you're using, what programming language you have used, and what version of Hadoop you are working on. So these are the main differences between Apache Pig and MapReduce. What are the different ways of executing Pig script? So you could create a script file, store it in .pig or .text, and then you could execute it using the pig command. You could be bringing up the grunt shell, that is Pig's shell. Now that usually starts with MapReduce mode, but then we can also bring it up in a local mode, and we can also run Pig embedded as an embedded script in other programming language. So these are the different ways of executing your Pig script. Now, what are the major components of Pig execution environment? This is a very common question. Interviewers would always want to know different components of Hive, different components of Pig, even different components which are involved in Hadoop ecosystem. So when we want to learn about major components of Pig execution environment, here are some. So you have Pig scripts. Now that is written in Pig Latin using built-in operators and user-defined functions and submitted to the execution environment. That's what happens when you would want to process the data using Pig. Now there is a parser which does type checking and checks the syntax of the script. The output of parser is a DAG, direct acyclic graph. So look in Wikipedia for DAG. So DAG is basically a sequence of steps which run in one direction. Then you have an optimizer. Now this optimizer performs optimization using merge, transform, split, etc. It aims to reduce the amount of data in the pipeline. That's the whole purpose of optimizer. you have a internal compiler. So Pig compiler converts the optimized code into a MapReduce job. And here user need not know the MapReduce programming model or how it works or how it is written. They all need to know about running the Pig script, which would be internally converted into a MapReduce job. And finally, we have an execution engine. So MapReduce jobs are submitted to the execution engine to generate the desired results. So these are major components of Pig execution environment. Now, let's learn about different complex data types in Pig. Pig supports various data types. The main ones are tuple, bag, and map. What is tuple or tuple? As you might have heard, a tuple is an ordered set of fields which can contain different data types for each field. So in array, you would have multiple elements, but that would be of same types. List can also have different types. Your tuple is a collection which has different fields, and each field can be of different type. Now we could have an example as 1, 3 or 1, 3, a string or a float element, and all of that form a tuple. Bag is a set of tuples. So that's represented by curly braces. So you could also imagine this like a dictionary which has various different collection elements. What is a map? Map is a set of key value pairs used to represent data. So when you work in big data field, you need to know about different data types which are supported by Pig, which are supported by Hive, which are supported in other components of Hadoop. So tuple, bag, map, array buffer. You can think about list, you can think about dictionaries, you can think about map, which is key value pair. So these are your different complex data types other than the primitive data types such as integer, character, string, boolean, float, and so on. Now, what are the various diagnostic operators available in Apache Pig? So these are some of the operators or options which you can give in a Pig script. You can do a dump. Now, dump operator runs the Pig Latin scripts and displays the result on the screen. So either I could do a dump and see the output on the screen, or I can even do a dump into and I could store my output in a particular file. So we can load the data using load operator in Pig. And then Pig also has different internal storage like JSON loader or Pig storage, which can be used if you're working on specific kind of data. And then you could do a dump either before processing or after processing, and dump would produce the result. The result could be stored in a file or seen on the screen. You also have a describe operator. Now that is used to view the schema of a relation. So you can load the data and then you can view the schema of relation using describe operator. Explain, as we might already know, displays the physical, logical, and MapReduce execution plans. So normally in RDBMS, when we use explain, we would like to see what happens behind the scenes when a particular script or a query runs. So we could load the data using load operator as in any other case. And if we would want to display the logical, physical, and MapReduce execution plans, we could use explain operator. There is also an illustrate operator. Now that gives the step-by-step execution of sequence of statements. So sometimes when we would want to analyze our script to see how good or bad they are, or would that really serve our purpose, we could use illustrate. And again, you can test that by loading the data using load operator, and you could just use a illustrate operator to have a look at the step-by-step execution of the sequence of statements which you would want to execute. So these are different diagnostic operators available in Apache Pig. Now, if somebody asks, state the usage of group, order by, and distinct keywords in Pig script. So as I said, Pig is a scripting language. So you could use various operators. So group basically collects various records with the same key and groups the data in one or more relations. Here is an example. You could do a group data. So that is basically a variable, or you can give some other name and you can say group relation name by age. Now say I have a file where I have various fields, and one of the field is a relation name. So I could group that by a different field. Order by is used to display the contents of relation in a sorted order, whether ascending or descending. So I could create a variable called relation2, and then I could say order relation name 1 by ascending or descending order. Distinct basically removes the duplicate records, and it is implemented only on entire records. not on individual records. So if you would want to find out the distinct values and relation name field, I could use distinct. What are the relational operators in Pig? So you have various relational operators which help data scientists or data analysts or developers who are analyzing the data, such as co-group, which joins two or more tables and then performs group operation on the joined table result. You have cross. It is used to compute the cross product, that is a Cartesian product of two or more relations. For each is basically to do some iteration. So if it will iterate through tuples of a relation, generating a data transformation. So for example, if I say variable A equals, and then I load a file in A, and then I could create a variable called B, where I could say for each A, I would want to do something, say group. Join is to join two or more tables in a relation. Limit is to limit the number of output tuples or output results. Split is to split the relation into two or more relations. Union is to get a combination, it will merge the contents of two or more relations. And order is to get a sorted result. So these are some relational operators which are extensively used in Pig for analysis. What is the use of having filters in Apache Pig? Now, say for example, I have some data which has three fields: year, product, quantity, and this is my phone sales data. So filter operator could be used to select the required values from a relation based on a condition. It also allows you to remove unwanted records from data file. So for example, filter the products where quantity is greater than 1000. So I see that I have one row wherein, or multiple rows where the quantity is greater than 1000, such as 1500, 1700, 1200. So I could create a variable called A. I would load my file using Pig storage. As I explained earlier, Pig storage is an internal parameter which can be used to specify the delimiters. Now here my delimiter is comma, so I could say using Pig storage as, and then I could specify the data type for each field. So year being integer, product being character array, and quantity being integer. Then B, I could say filter A, whatever we have in A, by quantity greater than 1000. So it's very concise, it's very simple, and it allows us to extract and process data in a simpler way. Now, suppose there is a file called test.txt having 150 records in HDFS. So this is a file which is stored on HDFS and it has 150 records, where we can consider every record being one line. And if somebody asks you to write a pig command to retrieve the first 10 records of the file, first we will have to load the data. So I could create a variable called test_data, and I would say load my file using Pig storage, specifying the delimiter as comma, as, and then I could specify my fields, whatever fields our file have. And then I would want to get only 10 records, for which I could use the limit operator. So I could say limit on test data and give me 10 records. This is very simple, and we can extract 10 records from 150 records which are stored in the file on HDFS. Now, we have learned on Pig, we have learned some questions on Hive. You could always look more in books like Programming in Hive or Programming in Pig and look for some more examples and try out these examples on a existing Hadoop setup. Now let's learn on HBase, which is a NoSQL database. Now HBase is a 4-dimensional database in comparison to your RDBMS, which usually are 2-dimensional. So RDBMS have rows and columns, but HBase has 4 coordinates. It has row key, which is always unique, column family, which can be any number, column qualifiers, which can again be any number per column family, and then you have a version. So these 4 coordinates make HBase a 4-dimensional key value store or a column family store, which is unique for storing huge amount of data and extracting data from HBase. There is a very good link which I would suggest everyone can look at if you would want to learn more on HBase, and you could just say HBase mapper. And this basically brings up a documentation which is from MapR, but then that's not specific to MapR. And you can look at this link, which will give you a detailed explanation of HBase, how it works, what are the architectural components, and how data is stored, and how it makes HBase a very powerful NoSQL database. So let's learn on some of the important or critical questions on HBase which might be asked by the interviewer in an interview when you're applying for a big data admin or a developer position role. So what are the key components of HBase? Now, as I said, this is one of the favorite questions of interviewers where they would want to understand your knowledge on different components for a particular service. HBase, as I said, is a NoSQL database, and that comes as a part of service with Cloudera or Hortonworks. And with Apache Hadoop, you could also set up HBase as an independent package. So what are the key components of HBase? HBase has a region server. Now, HBase follows the similar kind of topology like Hadoop. Now, Hadoop has a master process that is NameNode and slave processes such as data nodes and secondary NameNode. In the same way, HBase also has a master, which is HMaster, and the slave processes are called region servers. So these region servers are usually co-located with data nodes. However, it is not mandatory that if you have 100 data nodes, you would have 100 region servers. So it purely depends on admin. So what does this region server contain? So region server contains HBase tables that are divided horizontally into regions. Or you could say group of rows is called regions. So in HBase, you have two aspects. One is group of columns, which is called column family, and one is group of rows, which is called regions. Now these regions or these rows are grouped based on the key values, or I would say row keys, which are always unique. When you store your data in HBase, you would have data in the form of rows and columns. So group of rows are called regions, or you could say these are horizontal partitions of the table. So a region server manages these regions on the node where a data node is running. A region server can have up to 1,000 regions. It runs on every node and decides the size of region. So region server, as I said, is a slave process which is responsible for managing HBase data on the node. Each region server is a worker node or a worker process co-located with data node, which will take care of your read, write, update, delete request from the clients. Now, when we talk about more components of HBase, as I said, you have HMaster. So you would always have a connection coming in from a client or an application. What does HMaster do? It assigns regions. It monitors the region servers. It assigns regions to region servers for load balancing. And it cannot do that without the help of Zookeeper. So if we talk about components of HBase, there are three main components. You have Zookeeper, you have HMaster, and you have region server. Region server being the slave process, your HMaster being the master process, which takes care of all your table operations, assigning regions to the region servers, taking care of read and write requests which come from client. And for all of this, HMaster will take in help of Zookeeper, which is a centralized coordination service. So whenever a client wants to read or write or change the schema or any other metadata operations, it will contact HMaster. HMaster internally will contact Zookeeper. So you could have HBase set up also in high availability mode, where you could have a active HMaster and a backup HMaster. You would have a Zookeeper quorum, which is the way Zookeeper works. So Zookeeper is a centralized coordination service which will always run with a quorum of processes. So Zookeeper would always run with odd number of processes such as 3, 5, and 7. Because Zookeeper works on the concept of majority consensus. Now Zookeeper, which is a centralized coordination service, is keeping a track of all the servers which are alive, available, and also keeps a track of their status. For every server which Zookeeper is monitoring, Zookeeper keeps a session alive with that particular server. HMaster would always check with Zookeeper which region servers are available, alive, so that regions can be assigned to the region server. At one end, you have region server which are sending their status to the Zookeeper, indicating if they are ready for any kind of read or write operation. And at other end, HMaster is querying the Zookeeper to check the status. Now Zookeeper internally manages a meta table. Now that meta table will have information of which regions are residing on which region server and what row keys those regions contain. So in case of a read activity, HMaster will query Zookeeper to find out the region server which contains that meta table. Once HMaster gets the information of meta table, it can look into the meta table to find out the row keys and the corresponding region servers which contain the regions for those row keys. Now, if we would want to understand row key and column families in HBase, let's look at this, and it would be good if we could look this on an Excel sheet. So row key is always unique. It acts as a primary key for any HBase table. It allows logical grouping of cells and makes sure that all cells with the same row key are co-located on the same server. So as I said, you have 4 coordinates for HBase. You have a row key, which is always unique. You have column families, which is nothing but group of columns. And when I say column families, one column family can have any number of columns. So when I talk about HBase, HBase is 4-dimensional, and in terms of HBase, it is also called as a column-oriented database, which basically means that every row in one column could have a different data type. Now, you have a row key, which uniquely identifies the row. You have column families, which could be one or many, depending on how the table has been defined. And a column family can have any number of columns. Or I could say, for every row within a column family, you could have different number of columns. So I could say for my row 1, I could just have 2 columns such as name and city within the column family. For my row 2, I could have name, city, age, designation, salary. For my third row, I could have 1,000 columns, and all that could belong to one column family. So this is a horizontally scalable database. So column family consists of group of columns which is defined during table creation, and each column family can have any number of column qualifiers separated by a delimiter. Now, a combination of row key, column family, column qualifier such as name, city, age, and the value within the cell makes the HBase a unique 4-dimensional database. For more information, if you would want to learn on HBase, please refer this link, which is HBase Mapper, and this gives a complete HBase architecture. That is 3 components of NameNode, 3 components, that is NameNode, region servers, and Zookeeper, how it works, how HMaster interacts with Zookeeper, what Zookeeper does in coordination, how are the components working together, and how does HBase take care of read and write. Coming back and continuing, why do we need to disable a table? So there are different table operations what you can do in HBase, and one of them is disabling a table. Now, if you would want to check the status of table, you could check that by is disabled and giving the table name, or is enabled and the table name. So the question is, why do we need to disable a table? Now, if we would want to modify a table, or we are doing some kind of maintenance activity, in that case, we can disable the table so that we can modify or change its settings. When a table is disabled, it cannot be accessed through the scan command. Now, if we have to write a code to open a connection in HBase, now to interact with HBase, one could either use a graphical user interface such as Hue, or you could be using the command line HBase shell, or you could be using HBase admin API if you are working with Java, or say HBase if you are working with Python, where you may want to open a connection with HBase so that you can work with HBase programmatically. In that case, we have to create a configuration object, that is configuration myconf, and then create a configuration object. And then you can use different classes like HTableInterface to work on a new table. You could use HColumn qualifier and many other classes which are available in HBase admin API. What does replication mean in terms of HBase? So HBase, as I said, works in a cluster way. And when you talk about cluster, you could always set up a replication from one HBase cluster to other HBase cluster. So this replication feature in HBase provides a mechanism to copy data between clusters or sync the data between different clusters. This feature can be used as a disaster recovery solution that provides high availability for HBase. So if I have HBase cluster 1, where I have one master and multiple region servers running in a Hadoop cluster, I could use the same Hadoop cluster to create a HBase replica cluster, or I could have a totally different HBase replica cluster where my intention is that if things are changing in a particular table in cluster 1, I would want them to be replicated across different clusters. So I could alter the HBase table and set the replication scope to 1. Now, a replication scope of 0 indicates that table is not replicated. But if we set the replication to 1, we basically will have to set up a HBase cluster where we can replicate HBase tables data from cluster 1 to cluster. So these are the commands which can be used to enable replication and then replicate the data of table across clusters. Can we import and export in HBase? Of course we can. It is possible to import and export tables from one HBase cluster to other HBase cluster or even within a cluster. So we can use the HBase export utility, which comes in this particular package. Give a table name and then a target location. So that will export the data of a HBase table into a directory on HDFS. Then I could create a different table which would follow some kind of same definition as the table which was exported, and then I could use import to import the data from the directory on HDFS to my table. If you would want to learn more on HBase import and export, you could look at HBase import operations. Let's search for the link, and this is the link where you could learn more about HBase import export utilities, how you could do a bulk import, bulk export, which internally uses MapReduce, and then you could do a import and export into HBase tables. Moving further, what do we mean by compaction in HBase? Now we all know that HBase is a NoSQL database which can be used to store huge amount of data. However, whenever a data is written in HBase, it is first written to what we call as write ahead log and also to memstore, which is write cache. Now once the data is written in wall and your memstore, it is offloaded to form an internal HBase format file which is called H file. And usually these H files are very small in nature. So we also know that HDFS is good when we talk about few number of larger files in comparison to large number of smaller files due to the limitation of NameNode's memory. Compaction is process of merging HBase files, that is these smaller H files, into a single large file. This is done to reduce the amount of memory required to store the files and number of disk seeks needed. So we could have a lot of H files which get created when the data is written to HBase, and these smaller files can then be compacted through a major or minor compaction, creating one big H file which internally would then be written to HDFS and HDFS format of blocks. That is the benefit of compaction. There is also a feature called Bloom filter. So how does Bloom filter work? So Bloom filter or HBase Bloom filter is a mechanism to test whether a H file contains a specific row or a row column cell. Bloom filter is named after its creator, Burton Howard Bloom. It is a data structure which predicts whether a given element is a member of a set of data. It provides an in-memory index structure that reduces the disk reads and determines the probability of finding a row in a particular file. This is one of very useful features of HBase, which allows for faster access and avoids disk seeks. Does HBase have any concept of namespace? So namespace is when you have similar elements grouped together. So namespace, yes, HBase supports namespace. So namespace is a logical grouping of tables, analogous to a database in RDBMS. So you can create HBase namespace to the schema of RDBMS database. So you could create a namespace by saying create namespace and giving it a name. And then you could also list the tables within a namespace. You could create tables within a specific namespace. Now, this is usually done in production environment where a cluster might be multi-tenant cluster and there might be different users of the same NoSQL database. In that case, admin would create specific namespace, and for specific namespace, you would have different directories on HDFS, and users of a particular business unit or a team can work on their HBase objects within a specific namespace. This is a question which is again very important to understand about the writes or reads. So how does write ahead log wall help when a region server crashes? Now, as I said, when a write happens, it will happen into memstore and wall, that is your edit log or write ahead log. So whenever a write happens, it will happen in two places, memstore, which is the write cache, and wall, which is an edit log. Only when the data is written in both these places, and based on the limitation of memstore, the data will be flushed to create an HBase format file called hfile. These files are then compacted and created into one bigger file, which will then be stored on HDFS. And HDFS data, as we know, is stored in the form of blocks on the underlying data nodes. So if a region server hosting a memstore crashes, now where is region server running? That would be co-located with data node. So if a data node crashes, or if a region server which was hosting the memstore write cache crashes, data in memory, the data that in memory which was not persisted, is lost. Now, how does HBase recover from this? As I said, your data is written into wall and memstore at the same time. HBase recovers against that by writing to wall before the write completes. So whenever a write happens, it happens in memstore and wall at the same time. HBase cluster keeps a wall to record changes as they happen, and that's why we call it as also an edit log. If HBase goes down or the node that goes down, the data that was not flushed from memstore to hfile can be recovered by replaying the write ahead log, and that's the benefit of your edit log or write ahead log. Now, if we would have to write HBase command to list the contents and update the column families of a table, I could just do a scan, and that would give me complete data of a table. If you are very specific and if you would want to look at a particular row, then you could do a get table name and then give the row key. However, you could do a scan to get the complete data of a particular table. You could also do a describe to see what are the different column families. And if you would want to alter the table and add a new column family, it is very simple. You can just say alter, give the HBase table name, and then give your new column family name, which will then be added to the table. What are catalog tables in HBase? So as I mentioned, your Zookeeper knows the location of this internal catalog table, or what we call as the meta table. Now, catalog tables in HBase have two tables. One is HBase meta table and one is -root. The catalog table HBase meta exists as an HBase table and is filtered out of HBase shell's list command. So if I give a list command on HBase, it would list all the tables which HBase contains, but not the meta table. It's an internal table. This meta table keeps a list of all regions in the system and location of HBase meta stored in Zookeeper. So if somebody wants to find out or look for particular rows, they need to know the regions which contain that data, and those regions are located on region server. To get all this information, one has to look into this meta table. However, we will not be looking into meta table directly. We would just be giving a write or a read operation. Internally, your HBase master queries the Zookeeper. Zookeeper has the information of where the meta table exists, and that meta table which is existing on region server contains information of row keys and the region servers where those rows can be found. Your root table keeps a track of location of the meta table. What is hotspotting? in HBase and how to avoid hotspotting. Now, this is a common problem, and always admin guys or guys who are managing the infrastructure would think about it. So one of the main idea is that HBase would be leveraging the benefit of HDFS. Your all read and write requests should be uniformly distributed across all of the regions and region servers. Otherwise, what's the benefit of having a distributed cluster? So you would have your data stored across region servers in the form of regions, which are horizontal partitions of the table. And whenever read and write requests happen, they should be uniformly distributed across all the regions in the region servers. Now, hotspotting occurs when a given region serviced by a region server receives most or all of read and write requests, which is basically a unbalanced way of read-write operations. Now, hotspot can be avoided by designing the row key in such a way that data being written should go to multiple regions across the cluster. So you could do techniques such as salting, hashing, reversing the key, and many other techniques which are employed by users of HBase. We need to just make sure that when the regions are distributed across region servers, they should be spread across region servers so that your read and write request can be satisfied from different region servers in parallel, rather than all read and write requests hitting the same region server, overloading the region server, which may also lead to the crashing of a particular region server. So these were some of the important questions of HBase, and then there are many more. Please refer to the link which I specified during my discussion, and that gives you a detailed explanation of how HBase works. You can also look into HBase Definitive Guide by O'Reilly or HBase in Action, and these are really good books to understand about HBase internals and how it works. Now that we have learned on Hive, which is a data warehousing package, we have learned on Pig, which is a scripting or a scripting language which allows you to do data analysis, and we have learned some questions on a NoSQL database. Just note it that there are more than 225 NoSQL databases existing in market. And if you would want to learn and know about more NoSQL databases, you can just go to Google and type NoSQL databases.org, and that will take you to the link which is for NoSQL databases, and this shows there are more than 225 NoSQL databases existing in market, and these are for different use cases used by different users and with different features. So have a look at this link. Now, when you talk about data ingestion, so let's look at data ingestion, and this is one good link which I would suggest to have a look at, which lists down around 18 different ingestion tools. So when you talk about different data ingestion tools, some are for structured data, some are for streaming data, some are for data governance, some are for data ingestion and transformation, and so on. So have a look at this link, which also gives you a comparison of different data ingestion tools. So here, let's learn about some questions on Sqoop, which is one of the data ingestion tools mainly used for structured data, or you could say data which is coming in from RDBMS, or data which is already structured and you would want to ingest that. You would want to store that on HDFS, which could then be used for Hive, which could be used for any kind of processing using MapReduce or Hive or Pig or Spark or any other processing frameworks, or you would want to load that data into, say, Hive or HBase tables. Sqoop is mainly for structured data. It is extensively used when organizations are migrating from RDBMS to a big data platform, and they would be interested in ingesting the data, that is doing import and export of data from RDBMS to HDFS or vice versa. So let's learn about some important questions on Sqoop, which you may be asked by an interviewer when you apply for a big data related position. How is Sqoop different from Flume? So this is a very common question which is asked. Sqoop, which is mainly for structured data. So Sqoop works with RDBMS. It also works with NoSQL databases to import and export data. So you can import data into HDFS. You can import data into data warehousing packets such as Hive directly or also in HBase. And you could also export data from Hadoop ecosystem to your RDBMS. However, when it comes to Flume, Flume is more of a data ingestion tool which works with streaming data or unstructured data. So data which is constantly getting generated, for example, log files or metrics from server or some chat messenger and so on. So if you are interested in working on capturing and storing the streaming data in a storage layer such as HDFS or HBase, you could be using Flume. There could be other tools also like Kafka or Storm or Chukwa or Samza, NiFi, and so on. Sqoop, however, is mainly for structured data. Your loading data in Sqoop is not event driven, so it is not based on event. It basically works on data which is already stored in RDBMS. In terms of Flume, it is completely event driven. That is, as the messages or as the events happen, as the data is getting generated, you can have that data ingested using Flume. Sqoop works with structured data sources, and you have various Sqoop connectors which are used to fetch data from external data structures or RDBMS. So for every RDBMS such as MySQL, Oracle, DB2, Microsoft SQL Server, you have different connectors which are available. Flume, it works on fetching streaming data such as tweets or log files or server metrics from your different sources where the data is getting generated. And if you are interested in not only ingesting that data, which is getting generated in a streaming fashion, but if you would be interested in processing the data as it arrives. Sqoop can import data from RDBMS onto HDFS and also export it back to RDBMS. Flume is then used for streaming data. Now you could have one-to-one, one-to-many, or many-to-one kind of relation. So in terms of Flume, you have components such as your source, sink, and channel. That's the main difference between your Sqoop and Flume. What are the different file formats to import data using Sqoop? Well, there are lots and lots of formats in which you can import data into Sqoop. When you talk about Sqoop, you can have delimited text file format. Now that's the default import format. It can be specified explicitly using as text file argument. So when I want to import data from an RDBMS, I could get that data in HDFS using different compression schemes or in different formats using the specific arguments. So I could specify an argument which will write string-based representation of each record to output files with delimiters between individual columns and rows. So that is the default format which is used to import data using Sqoop. So to learn more about your Sqoop and different arguments which are available, you can click on sqoop.apache.org. You can look into the documentation, and I would suggest choosing one of the versions and looking into the user guide. And here you can search for arguments and look for specific control arguments which show how you can import data using Sqoop. So here we have common arguments, and then you also have import control arguments, wherein we have different options like getting data as avro, as sequence file, as text file, or parquet file. These are different formats. You can also get data in default compression scheme, that is gzip, or you can specify compression codec, and then you can specify what compression mechanism you would want to use when you're importing your data using Sqoop. When it comes to default format for Flume, we could say sequence file, which is a binary format that stores individual records in record-specific data types. So these data types are manifested as Java classes, and Sqoop will automatically generate these data types for you. So Sqoop does that. When we talk about your sequence file format, in terms of your Sqoop, you could be extracting storage of all data in binary representation. So as I mentioned, you can import data in different formats such as avro, parquet, sequence file, that is binary format or machine readable format. And then you could also have data in different compression schemes. Let me just show you some quick examples here. So if I look in the content, and here I could search for a Sqoop based file where I have listed down some examples. So if I would want to use different compression schemes, here are some examples. Have a look at these. So I'm doing a Sqoop import. I'm also giving an argument so that Sqoop, which also triggers a MapReduce job, or I would say map only job. So when you run a Sqoop import, it triggers a map only job. No reduce happens here. And you could specify this parameter or this argument on the command line mapreduce.framework.name so that you could run your map only job in a local mode to save time, or that would interact with yarn and run a full-fledged map only job. We can give the connection and then connect to whatever RDBMS we are connecting, mentioning the database name, give your username and password, give the table name, give a target directory, or it would create a directory same as the table name, which would work only once. And then I could say -z to get data in a compressed format, that is gzip, or I could be specifying compression codec, and then I could specify what compression codec I would want to use, say snappy, bzip, lz4, default. I could also run a query by giving a Sqoop import. And when I'm specifying a query, if you notice, I've not given any table name because that would be included in the query. I can get my data as a sequence file format, which is a binary format, which will create a huge file. So we could also have compression enabled. And then I could say the output of my map job should use a compression at record level for my data coming in sequence file. So sequence file or a binary format supports compression at record level or at block level. I could get my data in a Avro file where data has embedded schema within the file, or a Parquet file also. So these are different ways in which you can set up different compression schemes, or you can even get data in different formats, and you could be doing a simple Sqoop import for these. Looking further, what is the importance of eval tool in Sqoop? So there is something called as eval tool. So Sqoop eval tool allows users to execute user-defined queries against respective database servers and preview the result in the console. So either I could be running a straight away query to import the data into my HDFS, or I could just use Sqoop eval, connect to my external RDBMS, specify my username and password, and then I could be giving in a query to see what would be the result of the query which we intend to import. Now, let's learn about how Sqoop imports and exports data between RDBMS and HDFS with its architecture. So RDBMS, as we know, has your database structures, your tables, which all of them are logical. And internally, there is always metadata which is stored. Your Sqoop import connects to an external RDBMS, and for this connection, it uses an internal connector jar file which has a driver class. So that's something which needs to be set up by admin, but they need to make sure that whichever RDBMS you intend to connect to, they need to have the JDBC connector for that particular RDBMS stored within the Sqoop lib folder. So Sqoop import gets the metadata, and then for your Sqoop command, it converts that into a map only job, which might have one or multiple map tasks. Now that depends on your Sqoop command. You could be specifying that you would want to do a import only in one task or in multiple tasks. These multiple map tasks will then run on a section of data from RDBMS and then store it in HDFS. So at high level, we could say Sqoop will introspect database to gather the metadata. It divides the input data set into splits, and this division of data into splits mainly happens on primary key column of the table. Now, if somebody might ask, what if my table in RDBMS does not have a primary key column? Then when you're doing a Sqoop import, either you will have to import it using one mapper task by specifying -m equals 1, or you would have to say split by parameter to specify a numeric column from RDBMS. And that's how you can import the data. Let me just show you a quick example on this. So I could just look in again into the Sqoop command file, and here we could be looking at an example. So if you see this one, here we are specifying minus minus m equals 1, which basically means I would want to import the data using one map task. Now in this case, whether the table has a primary key column or does not have a primary key column will not matter. But if I say a minus minus ms6 where I'm specifying multiple map tasks to be imported, then this will look for a primary key column in the table which you are importing. Now, if the table does not have a primary key column, then I could be specifying a split by and then specify the column so that the data could be split into multiple chunks and multiple map tasks could take it. Now, if the second scenario is your table does not have a primary key column and it does not have a numeric column on which you could do a split by. In that case, and if you would want to use multiple mappers, you could still say split by on a textual column, but you will have to add this property so that it allows splitting the data which is non-numeric. All of these options are given in the sqoopapache.org link. Going further, how Sqoop imports and exports data between RDBMS and HDFS with its architecture. So as I said, it submits the map only job to the cluster and then it basically does a import or export. So if we are exporting the data from HDFS, in that case again there would be a map only job. It would look at multiple splits of the data which is existing, which your map only job would process through one or multiple map task and then export it to RDBMS. Suppose you have a database test DB in MySQL. If somebody asked you to write a command to connect this database and import tables to Sqoop. So here is a quick example as I showed you in the command file. So you could say Sqoop import. This is what we would want to do. You connect using JDBC. Now this will only work if the JDBC connector already exists within your Sqoop lib directory. Admin has to set up that so you can connect to your RDBMS. You can point to the database. So here our database name is test_db. I could give username and then either I could give password on the command line or just say capital P so that I could be prompted for the password, and then I could give the table name which I would want to import. I could also be specifying minus minus m and specify how many map tasks do I want to use for this import, as I showed in previous screen. How to export a table back to RDBMS? Now for this, we need the data in a directory on HDFS. So for example, there is a departments table in retail database, which is already imported into Sqoop, and you need to export this table back to RDBMS. So this is the content of the table. Now create a new department table in RDBMS. So I could create a table specifying the column names, whether that supports null or no, if that has a primary key column, which is always recommended. And then I can do a Sqoop export. I can connect to the RDBMS, specifying my username and password, specify the table into which you want to export the data, and then you give export directory pointing to a directory on HDFS which contains the data. This is how you can export data into table. Seeing example on this. So I could again look into my file, and here I have an example of import. This is where you are importing data directly into Hive. And you have Sqoop import where you are importing data directly into HBase table, and you can then query your HBase table to look at the data. You could also do a export by running your map only job in a local mode, connecting to the RDBMS, specifying your username, specifying the table where you would want to export, and the directory on HDFS where you have kept the relevant data. This is a simple example of export. Looking further, what is the role of JDBC driver in Sqoop setup? So as I said, if you would want to use Sqoop to connect to an external RDBMS, we need the JDBC ODBC connector jar file. Now, one or admin could download the JDBC connector jar file and then place the jar file within the Sqoop lib directory wherever Sqoop is installed. And this JDBC connector jar file contains a driver. Now JDBC driver is a standard Java API which is used for accessing different databases in RDBMS. So this connector jar file is very much required, and this connector jar file has a driver class, and this driver class enables the connection between your RDBMS and your Hadoop structure. Each database vendor is responsible for writing their own implementation that will allow communication with the corresponding database, and we need to download the drivers which allow our Sqoop to connect to external RDBMS. So your JDBC driver alone is not enough to connect to Sqoop. We also need connectors to interact with different databases. So a connector is a pluggable piece that is used to fetch metadata and allow Sqoop to overcome the differences in SQL dialects. So this is how connection can be established. So normally your admins would, when they are setting up Sqoop and Hadoop, they would download, say, MySQL JDBC connector, and this is how they would go to the MySQL connectors. If you are connecting to MySQL, similarly for your other RDBMS, you could be, say, going in here, you could be looking for a previous version, depending, you could be going for platform independent, and then you could be downloading the connector jar file. Now, if you untar this jar file, you would see a MySQL connector jar. And if we look in com.mysql.jdbc.com.mysql.jdbc.driver, so this is the package which is within the connector jar file, and this has the driver class which allows the connection of your Sqoop with your RDBMS. So these things will have to be done by your admin so that you can have your Sqoop connecting to an external RDBMS. Now, how do you update the columns that are already exported? So if I do a export and I put my data in RDBMS, can I really update the columns that are already exported? Yes, I can, using a update key parameter. So Sqoop export command remains the same. The only thing I will have to specify now is the table name, your fields terminated by if you have a specific delimiter, and then you can say update key and then the column name. So this allows us to update the columns that are already exported in RDBMS. What is CodeGen? So Sqoop commands translate into your MapReduce job or map only job. So CodeGen is basically a tool in Sqoop that generates data access objects, DAO, Java classes that encapsulate and interpret imported records. So if I do a Sqoop CodeGen connect to an RDBMS using my username and give a table, this will generate a Java code for employee table in the test database. So this CodeGen can be useful for us to understand what data we have in this particular table. Finally, can Sqoop be used to convert data in different formats? I think I already answered that, right? If no, which tools can be used for this purpose? So Sqoop can be used to convert data in different formats, and that depends on the different arguments which you use when you do a import, such as Avro file, Parquet file, binary format with record or block level compression. So if you're interested in knowing more on different data formats, then I think I can suggest a link for that, and we can say Hadoop formats. I think it is Tech, Maggie, Avro, Parquet. Let's see if we can find the link. Tech, Maggie. Yeah, this is a very good link which specifies or talks about different data formats which you should know, such as your text file format, different compression schemes, how is data organization, what are the common formats, what do you have in text file, structured, binary, sequence files with compression, without compression, what is record level, what is block level, what is a Avro data file, what is a sequence, what is a Parquet data file or a columnar format, and other formats like ORC, RC, and so on. So please have a look at this link. So here we have learned on some important questions on your Hive, which is a data warehousing package, HBase, which is a NoSQL database, Pig, which is a scripting language used for data processing and analysis, and Sqoop, which is used for ingestion of structured data. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.